Alright guys, you're welcome to our next tutorial series on the object detection, which is a research area in computer vision. So um, for the next few tutorials we shall be looking at some important terminologies that are very necessary for us to be able to understand research papers in computer vision and especially in object detection. There are a number of those terminologies, and we will try to pick each one of them and dissect them to understand them. So, once we understand these terminologies very well, it will be easy for us to be able to understand the research papers that we discuss in computer vision. So some of them are basic concept, like the one we would consider now is intersection over union. We have some terminology like non-mark suppressions. Uh, so we have some terminology like deformable path models. We have terminologies like um, okay. There's another very common one that we see, like RPN, Region Proposal Network. So there are a number of terminologies like that that we'll uh, look through one after the other in details so that we understand how they work. So today we look at intersection over union. It's just a ratio of your ground truth and your predicted area. When you're doing object detection, your object of interest, before you start your training, you will have annotated that object by drawing a box around your object. That box is your ground truth. Then, when you train your model, while training your model, you are actually teaching your model how to draw the bounding box around your object, and you are minimizing a loss function in such that your model prediction is as close as your ground truth. I repeat that. You are trying to minimize an objective function in such a way that the bounding box model's prediction is as accurate as the ground truth. So here is a visual explanation. In this case, they actually use circle, but in the object detection, we normally use rectangle boxes. So, so the IOU is simply the area of overlap, also known as the area of intersection, divided by the area of union. So let's say, for instance, that in this place, let me pick my okay. So let's say, for instance, this circle is your ground truth, and this is your model prediction. So this is your model prediction, and this is your ground truth. So you will have an ideal situation when the circle of your model prediction covers completely the circle of your ground truth. In that situation, you will have an IOU of 1, which is the ideal situation. But because you are teaching your model to minimize a loss function, most times your model will not be able to get exactly 1, but as it approaches 1, the better it is for the model. So like in this case now, so you check the intersection or the overlap between your model prediction and your ground truth on the object. So you see that this is a place that is common. So that means your model is correct in this area. But you penalize your model by how much it has missed. So you are penalizing it by how much that was missed. So by doing that, you divide by the total area of union. So you can see in this case that if your model is completely, if this circle is completely insert inside this place, then this place too will also be completely inside this. Then you will have 100% here, and you also have 100% here. So the area here will be equal to the area here. But if this is completely apart, let's say this is the ground truth and this is your model prediction, you see that your model got it completely wrong. So the intersection is 0. So definitely, no matter what the union is, you are going to get 0, which is bad for your model. You want your model to approach 1. So that's just the concept behind that. So and there's a script here for in Python to be able to generate that. Essentially, that is what the intersection over union is saying. All right, thank you for listening. I hope someone will have gotten clarity about this. Do give us a like if you have benefited, and then leave comment. Thank you. See you in the next one.